So I just want to introduce Matt, who is going to teach the course for you. He's really clever, so listen to what he has to say and have fun.
Okay guys, so so I'm on the EARS committee. I'm Matt Isbell. I'm currently the IT admin for EARS, but I've been on the committee for the last 2 years and I've been involved in quite a few projects using Arduinos, so I'm teaching the course this year. So this lecture is just an introduction to Arduinos, the basics of how to actually program it, how to start with it. So there's nothing too complicated to get, making sure that all your computers are set up properly and everything, so that in the coming lectures we can work on more complicated things and get more advanced with it. So what is EARS? You're all here, so you obviously know that we exist, which is always good. So the Electronics and Amateur Radio Society, we actually predate this university, which is quite achievement for a university society. So we were founded, I have no idea what the date is. James, you know the date? 60s somewhere, isn't it?
In theory, it's before the 60s, but we can trace it back definitely to 1960.
There you go. So at least before 1960, EARS was founded when the university was back at Battersea Polytechnic. So we moved over here with it, which is why we're one of the few societies that actually have a room on campus, which we call the Shack, which you may or may not have visited and done chat test for to use whenever you like. So we focus on projects, and we're quite driven by what you guys want to do. We don't dictate anything. We have a bunch of projects that are ongoing. You're welcome to join them, but mostly it's what you guys want to do, and we're just facilitating that, which is what this course is for, to give you the tools to start doing whatever you want. So the assumptions for this course: hopefully at least half of you have laptops, because the kits we've got are working in pairs. So hopefully we've got at least that many. Hopefully you've all got the Arduino software. Has anyone not managed to install that? 2, excellent. James?
Yep.
Fix that. This is why I've got all these people sitting at the back, so they can do this work. So as we go along, we're going to teach you right from the ground up. There's no presumed knowledge apart from the... Actually, no, there is no presumed knowledge at all with this. We'll teach you right from the ground up. The reason I keep saying Sebastian Goscik in the corner is because he was last year's electronics officer. He wrote this course, but he's on placement this year, so he can't present it for us. Okay, so this is the approximate structure of the course. Some of these dates might change, but they should be about here. That one is definitely changing, apparently. So we're starting off with basics, just an introduction, how to make it blink LEDs, how to get programs onto it, how to set up your computer, all that sort of stuff. Next week we're going into some of the more detailed of it, what extra functions you can get from the pins of it, what extra functions are built into the microcontrollers. Week after that, it's how we're talking to other devices, so not only its own functions, but what extra things you can connect to it and how you talk to them to make it do something more interesting, more complex. The next week follows on, same kind of thing, talking to external devices, getting more complex, getting you more interesting things, more advanced features, leading up to the final project, which will involve you all making some sort of like a module that will then network together, and they'll all be working. Last year it's a traffic light system, it may or may not change. So, there's a bunch of kits at the front, which we'll distribute around in a bit, but they've got a bunch of basic components in them. So we've just got a breadboard LED, an RGB LED, buzzer, some resistors, a USB cable, and the important bit, the Arduino. So they're all at the front. We'll pass them around in a minute. Can someone pass them around now? Yeah. So I'm just going to pass these kits around to you. Feel free to open them up. There are some small resistors and things in there, so try not to drop them on the floor. We do have hidden spares, but... So what is an Arduino? Probably one of the most important things with this. What we've got is it's basically a microcontroller development board. So this whole chunk here is the microcontroller itself. So this has got all sorts of technologies within it that will allow you to program it and make all the pins toggle and do all sorts of extra functions. So the standard Arduino board that we're using today is the Arduino Uno. Although I think they've changed. So So still the Arduino Uno, it's the basic level of the board. This one has 14 digital input and output pins, and 6 PWM output pins, which is kind of analog and not. It's as close to analog as you can get with a digital signal. So USB connection to your computer runs at 16 megahertz clock, has 12 kilobytes of flash, 50 kilobytes of RAM, and keyboard. So different memories it's got on here. You've got 32 kilobytes for your program code, minus half a kilobyte for its bootloader, so you've got 1.5 kilobytes for all your code in. The 2 kilobytes of SRAM for your variables and that kind of stuff, and 1 kilobyte of EEPROM allows you to store all of your values that you want to keep between power cycles, basically. So the RAM will reset, the EEPROM will store your values, and we'll keep trying to use that in the third lecture, I think. So, you should all hopefully have seen this window at some point if you've installed the software. So we've got, this is the Arduino IDE, something development environment. I'll go with independent development environment. So this is specifically for programming Arduinos, although it's been branched out a lot to program a lot of different microcontrollers now. So we're going to go through the basic features. If you've got it open on your laptops, you can look at them and click with it and mess through as we're going along. So the most important bit you will need is the code area. It's the main chunk of the window, that's where you will be typing your code. Yeah, it's the most important part, obviously, because it's where you put everything you want to run. The info panel at the bottom will indicate what is currently going on in the background. So when you start compiling and programming your code, this will give you feedback, show errors if you've got it wrong. Do read what it says. Usually it will say you've got an error on this line, which is very helpful to try and fix it. Unless it's a more complex error, in which case it won't have a clue. But it should tell you towards where it is. So yeah, the important buttons you've got across the top. The first one is the verify button. This button allows you to compile the code and make sure that the code is actually right and will run before you even upload it into your Arduino. You don't even have to have hardware with you. If you're programming anywhere, hit this button, you can just, it will show any errors that you want to block. The upload button does exactly the same thing, but then uploads it to your hardware afterwards. So it compiles all your code, checks for errors, tells you about the errors if there are any. If you do get errors, it doesn't upload it, obviously, because that would be very helpful. So, yeah, so that's how you actually upload it to the Arduino itself. And a useful extra one is a little magnifying glass, if we want to call it, it's the serial monitor. So that's where you can send commands over the serial port to the Arduino and read back the things it's telling you. Again, that's in the second lecture, I think. We'll actually be using that to make, because you can make more complex features because you've got the user interaction with it. So, one of the most important things that they've got here is there are a large quantity of examples built in. So if you're just getting started, as I'm assuming most of you guys are, there's loads of examples just in the file menu. There's loads of things in there take you through from blinking LEDs to talking to all sorts of extra stuff. So you should all have at least this first set of examples. Probably most of these are all built in, they're all the standard kind of things. My list actually falls off the bottom of the screen because I've installed so many extra libraries and stuff, which all come with examples to show you how to use it. So you've got one for a particular temperature sensor on there. But yeah, so they're an excellent place to start. They show you through loads of things. Some of what we're doing is based on those this week. Okay, and as it says at the bottom slide, it's not an example, so someone will have tried to do it, ask this question, so it'll be on Google somewhere or on the Arduino forums. There are loads of people there. If you sign up to them, they're happy to help with pretty much anything. Sorry. So the two things that are most important before you begin. So, as I said, the Arduino environment is designed to program a lot of different boards. We're using the most basic Arduino board, the Arduino Uno, but there are a lot more complex ones and more advanced ones that you can pick up. So it's very important you have to tell it which one you are using. To do this, it's under the Tools menu, you select Board, and then you see you've got this huge list of different things. You just pick out the Arduino Uno, or whichever one you happen to be using. The other thing you'll need to do is tell it which serial port you've connected your Arduino to. And of course, because we are in the USB age, they're all virtual serial ports, they keep changing numbers. So this is something you should check up on when you try to upload if you get an upload error. It can be that it doesn't know which port it's actually on. If it comes up with multiple ports like this, you've got several devices on your system, it doesn't know which one's which, you have to pick whichever one the Arduino is. If you don't know which one it is, you can look in the device manager on the computer, it should list under COM ports. If you run into this problem, we can show you later on when we go through. So, the structure of the the structure of the sketch. So Arduino has decided to call all its programs sketches. So the structure is literally this. This is what the IDE usually opens up with when you open it up the first time. So there's two parts to it basically. You've got the setup part, it will run once when the microcontroller powers up. So that's configuring your pins, settings of variables, all that sort of stuff when you start. And the loop will just keep going around forever. So whatever you put in there, it will just keep running repeatedly until the power turns off or you blow it up or block it or something. Yeah, so that's where you need to put the two main parts of this. This one is found in, this is in the examples, it's in examples part 1 basics, bare minimum, but it opens up whenever you start a new sketch, so you can just type in your code into it. So, this is the first sketch we're going to be doing today. You guys can open up your kits and do this now if you like. So what we've got, this is a basic program to flash an LED, so it turns it on and off every second. So, very simple piece of code. First off, we set up just a global variable. This means that for those of you who don't know the programming, this means that any of the functions or anything else we write can access this variable. In this case, in the setup, we set a variable to value 13. So we're using that to define which pin we are using. So pin 13 has a built-in LED on the Arduino, so you can connect one externally as well if you want. Which we'll show you in a minute. Sorry. So, yes, so the next thing, we've got pin mode. This sets whether your pin is being an input or an output. So obviously because we're trying to drive an LED, we want it to be outputting power. If you set it to input, it allows you to detect levels from buttons or other devices or whatever you're using. For those of you who know any programming, it's based on C-ish. It's approximately based on C. There are a few little things that are tweaked in it, but it's mostly the same kind of stuff. Those of you who don't know programming, the format is, this is a function. So this basically can be called by this name from anywhere, and then it will run whatever is inside these kernel brackets. This void here is the return type of the function. Void just means it's not going to return anything. So it will just run through and won't tell anything back to whatever called, which for these main functions is what you want. This line is a comment line. It's got 2 slashes on the start. It just means that when it's compiling it completely ignores it. That's just for you to make it more readable and to remember things. So what we've got, so then we get down to the main loop. So we set the pin mode, we set it to an output. And we get down to the main loop, we want to tell it what we want that output to be. So you tell it it's a digital write because we want a digital level, so it's either high or low, which in this case is 5 volts or 0 volts. And you tell it to write to this pin, which we set as a variable so we can change it whenever we like. And you tell it to set it to high. Very simple, that has been capital, otherwise it doesn't like you. So then simply we just delay, which is in milliseconds, so delay 500, delay half a second. And then you set it to low, which turn the LED off again. And that will just loop around forever, turn the LED on and off once a second. Yeah, so if you guys want to have a go at that, we'll have some demonstrators wandering around, check how it's going. There'll be an LED actually on the board you can use. So you should be able to write this code into it and you should see an LED. You've probably figured this out already, how to actually use the breadboards. I've seen some of you actually got blinking LEDs external from your board. Sorry. For those of you who don't know, every single one of these boards you can poke a wire through, and they will connect as these red lines are shown. So each of these sets are connected this way, and these ones are connected along the length to allow you to make power. Some of you have larger boards, they follow the same principle. The ones with the stripes connect along length, the short ones just connect to the other cells. So, some of you have noticed already that there is another sort of LED in your kit. This is an LED. Effectively, it's got 3 LEDs built into the same casing. They've got red, green, and blue.
So the
The ones we've got are common cathode LEDs. So the negative side is common, you apply a positive to 3 different pins depending on which colour you want. The way you tell which around the LED is one side of it has a flap on it. So this is actually like a brim on a hat that goes most of the way around, but one side is flattened off. So that's how you tell what order the pins are in. It's the same principle with a normal LED, except you haven't put the flap bit on. The flap bit used on a normal LED will indicate the negative side. It's very important that LED you connect it the right way around. They are one-directional devices. If you connect them backwards, they won't light up. If you connect them backwards with enough voltage, they'll explode quite hilariously. But please don't do that. So the other thing with LEDs is they run at a considerably lower voltage than the Arduino does. The Arduino is outputting 5 volts, the LEDs usually want about 1.8, 2 volts, somewhere around there. So in your kits you've also got a resistor to go with it. So you chain this in series with the LED, as in the diagram. You've got your Arduino, run it through a resistor, through the LED. This drops some voltage and limits the current of the LED, stops it blowing up and breaking. This is approximately how you connect it to your actual Arduino. I know a few of you have done it, try it in a bit. Now turning an LED on and off just isn't quite as interesting as making it do different brightnesses. So to achieve this we use pulse width modulation. The Arduino itself can't output an analog signal. So in order to trick your eyes into thinking it's an analog signal, it turns it on and off so fast you can't actually tell. And it's called pulse width modulation because it's the width of the pulse that sets the brightness, basically. So if it's on, it's like this. This is 0 pulse width, or off. If you've got 50% pulse width, it's on half the time, so it looks half as bright, apart from that your eyes are sort of logarithmic. So it's theoretically half as bright. And you can pick anything in between, so you have varying levels of brightness. This is built in on particular pins, 3, 5, 6, 9, 10 and 11. They usually have a little squiggle next to them on the board to indicate that they can output this sort of waveform. You can do different brightnesses with the LEDs. So, to program a PWM output is like this. It's the same kind of thing. You're setting up your pin, you've got your setup, tell it which thing it is. This one, you do not have to put pin mode on it. PWM is output only, so you don't have to tell it that it's an output. It knows it by default. Basically, what's different is you've got analog write, so digital write, and you say LED pin, and then you've got 50 to 255, I believe. 255 is fully on, 0 is off, so 50 is some random proportion in the middle. So that's on about a fifth of the brightness. 255 is fully on, full brightness. And you can pick any number in between. So this one just alternates between 2 different brightnesses. Yeah, so if you guys want to have a quick go at doing this PWM, you're connecting a single LED on the outside. Something that makes it powerful with a microcontroller. Blinking LED is easy to do. You can do just a straight hardware, it's not that complicated, just a simple timer, you can do it. What's interesting is when you start doing it on microcontrollers, you can have loops. I know we've used up blinking already, but you can do more interesting things with them. So a loop, as you might expect, loops around several times. The main loop you've got, that just loops around forever. This is a for loop, so it loops around using conditions. So there's 3 parts to it. This is the syntax for using it. You've got the for, within the brackets you set your 3 sections that tell it how it should loop, and within the curly brackets you've got the code it should run every time. The first bit you've got is the initialization. So this will run once, right at the start. If you put brackets in here, you can put literally any code in there. With the curly brackets, but usually you'll just set up a counter. This is why I said it's C-ish. For those who didn't know, that's a C++ statement. So usually you just initialize a counter to 0 or whatever number you want to start at. The next section you've got is the condition. So this will loop around while this condition is true. So in this case, it's looping around while the counter is less than 10. You can put more than 10, less than a billion, whatever. As long as it makes sense with your variables. On the back of your sheets it says about variable types, they have maximum and minimum values. If it counts over it, your condition might be true forever or never be true. Yeah, so that gets checked every time you run through your code. Sorry, it checks that. If it's true, it will run whatever code you have. Once it has run the code, it will then do this piece of code. In this case, adds 1 to the counter. So then, when it runs through again, it keeps checking, so this will obviously run through 10 times. This is very useful. You can make it change brightnesses or do all sorts of different things. So there's another type of loop. This is the while loop. So this has a lot less things in it. It doesn't have the initialization or the counter incrementing. So this one simply, while that statement is true, it will run whatever's in the loop forever. So if you put while 1 there, it will run it until you run out of power. So in this case, it's reading a pin while it's low. So if you put a button on it, while the button isn't pressed, for example, it will run the code. When you press the button, it'll stop running it. Something like that. Yeah, so those are the 2 types of loops. There's examples and more explanations around online. They are basically what makes it more powerful. You know, just blinking LEDs. Yeah, while interesting, not so useful. You can loop it and make it do different things every loop. It makes it more interesting. So what we've got is a couple of sort of challenges here. Although quite a lot of you have probably already done most of them. So these are using the RGB LED you've got, which is effectively 3 LEDs built into one. You've got pinouts on your sheet, but positives and negatives are backwards just to confuse you. So if you want to have a go at just making it do all the different colour combinations and then put fading on it as well, you can get an almost infinite number of colours out of it.